Okay, to sketch a graph, we have to know the formula of tan graph with modified period first. For formula is equal y equal to a tan bx plus c. C is the axis of the curve. B is the value that we will use to divide the period. And other scale or asymptote and amplitude is equal to a. Because we have a modified period, so we have to find the period for this graph first. Normal period for the tan graph is equal to 180, but because we have a modified period, which is 2x, so we have to divide it by b, which is 2, and we will get 90 degree as a period for this graph. Then we have to find the scale on x-axis. For normal scale on x-axis is equal to 45 degrees, but because we have a modified graph, so we have to divide it by b again, which is 2, and we will get 22.5 degree for the scale on the x-axis. Then we plot on the x-axis, and from 0 until 360, because the domain that we get is between 0 and 360. Then we have to find the asymptote. For the asymptote for tan graph, normal tan graph is 90, 270, and so on. But because we have a modified graph, so we have to divide it by 2. 90 divided by 2, and we will get 45 degree, and we plus by 90, 135 degree, 225 degrees, and so on. You may be hesitated why we can do by plus 90 degree. I will show you why. It is because the period of this graph is 90, so we can plus by 90 degree and get another asymptote. When we get the asymptote, I suggest you to plot dotted line on the graph, so you know that as your graph doesn't collapse with the asymptote. Then we have to find the y value. For the y value, we use a middle point or middle line, but because we don't have a maximum or minimum point, we just use a higher point and lower point. To find the midpoint or midline is the C. C is the axis of the curve. So axis of the curve is for this graph is 2, so midline is 2. Then for finding the higher point that we will use is C plus A. So we get 2 plus 1, which is equal to 3. And for the last one is axis of the curve minus amplitude, which is we will get the lower point, C minus A. So 2 minus 1 equal to 1. Then we plot the graph as a normal tan graph. And when we get to 90 degree for the x-axis, it will repeat itself as the tan graph. But because we have the absolute value, so the value of y cannot be negative. Then the graph that have a negative side down to the negative side will be bounce on the x-axis back to the positive side only, and we will get this graph. Make sure that your graph doesn't intersect with the asymptote, because if you do that, it will be wrong. Then you connect the line together, and this is the result from the graph of y equal to absolute tan 2x plus 2 for the domain between 0 degrees and 360 degrees.